In this video, I am going to solve a sample problem on buoyancy. Here's the problem. A wooden pole weighing 2 pounds per foot has a cross-sectional area of 7 inch square and is supported as shown in the figure. The hinge is frictionless. Find theta. Okay. First to do is to determine or to identify the forces. One of them is the weight. No. Weight of the pole, and the weight is acting at the center of gravity. Downward, this is W, and since the length of the pole is 10 feet, then the distance of the point of location sa W or the center of gravity from the hinge is 5 feet. Okay. And the other force is the buoyant force, which is acting on that portion which is submerged or in contact with the liquid or oil, this part. So we have an upward force, the buoyant force. So next is we apply equilibrium equation, and to get rid of the reactions, we will use summation of moment about hinge para dili ma-include ang reactions. Summation of moment about the hinge equal to 0. So next is we will determine the distance, the perpendicular distance of W and buoyant force. So for the weight, considering this triangle, we have the hypotenuse of 5, and considering this angle theta, this is the opposite side, no? So therefore this side is 5 sine theta. And for the buoyant force, first is we denote the length of the submerged part as x, and the buoyant force is also acting at the center of gravity of the submerged portion. So therefore, the location of the buoyant force from the hinge is equal to 10 minus x over to 1/2 of x. And considering this triangle, the perpendicular distance of the buoyant force from the hinge is the opposite side. So hypotenuse times sine of theta. And so after this, we now sum up moment about the hinge. So counterclockwise positive. So the moment of the buoyant force is counterclockwise, while ang sa weight is clockwise. So here's the equation. Force times distance, force times distance. Next is we transpose these terms right. And then we now compute the value of the magnitude of W and the buoyant force. So for weight, the wooden pole weighs 2 pounds per foot. And since we have a length of 10 feet, the weight is equal to 20 pounds. For the buoyant force, the magnitude of the buoyant force is equal to the specific weight of the liquid times the volume displaced. Now, given ang specific weight of oil, so for the volume displaced, it's equal to cross-sectional area times length, volume. And since the unit of gamma is pounds per cubic feet, we will convert area from inch square to feet square. And x is in feet man. So therefore, the buoyant force is equal to this one. Oh, sige po. 52 pounds per cubic feet times 7-inch square conversion factor times x. And makancel ng feet cube ni inch square, makancel feet square and feet, makancel sa feet cube. And so the simplified, the value is this one. 91 over 36x pounds. So after this, we will substitute, we will cancel sine theta. And then for BF, we will substitute 91 over 36x. And for W, we will substitute 20 times 5, that's 100. And if you will distribute these terms, second term, the highest power of x is 2. It means na there are two possible roots or two possible values of x. One of them is correct. The other one is it's more than 10 feet, so it's not acceptable. So only one value is correct. So, and using your calculator, you can use shift solve. The answer is this, no? Input mo 91 over 36x times 10 minus x over 2 equals 100. Shift solve, and the answer is 5.4306, which is acceptable since x should be less than 10. So after solving for x, we can now solve for theta. Okay. So to solve for theta, we now consider this portion. We've given adjusted side of 4 feet. So we now compute this length. And this is 10 minus x. That's 10 minus x. And considering this triangle, theta, adjacent, and hypotenuse. So we will use cosine. Cosine of theta, that's 4 over 10 minus x. And after this, we substitute the value of x. You divide. And then after this, inverse cosine. And we have the value of theta, 28.91. So that's it. I hope that you have learned something. And thank you for watching.